All right. Good morning, everyone. So how did you like the fireworks last night? Oh, right. I think it was amazing. All right, so welcome everyone on the day 2. Before we start, before we have our first keynote session, I have a couple announcements here. So where should I start? First thing, we will have a couple lightning talks today. Lightning talks, the sign up will start at 11 a.m. on the whiteboard in front of the D room. So if you have some interesting topic for a lightning talks are 5 minutes maximum, no slides usually. Make sure you sign up there. And for everyone else, if you see some interesting topic on the table, on the whiteboard, put your +1 there. Check or something so we know which talks you are interested in. Lightning talks will be today at 5 p.m. and it's going to be an hour and 15-minute session where everyone gets their 5 minutes of fame and they can present their stuff. Lightning talks, another thing, there are a couple workshops today again. One quick announce, take a look at the Atomic workshop if you want to come to that one. There are some prerequisites, you should download something before the workshop. And since we have somehow crappy internet connection here, make sure you do this ahead of time. As you've seen probably yesterday, food, same deal like yesterday. Mensa, the school canteen, opens at 11, and food trucks are coming again in the afternoon, and they will open slightly before 2 p.m. Before that, in the room 8211 today, you have a chance to get a massage. So we have a massage room, and at the door, I think it's close to the door of the massage room, there is a sign-up sheet. So if you want to get a free massage today, you can. Make sure you sign up there. Some people mentioned that they really need it after last night's party. I don't know what you've done, but talking about parties, so the last and the most important thing. Party starts tonight at 7 p.m. If you didn't get this small badge, make sure you stop by at the entrance. Make sure you smile at the girls there, and you will get one. There are still a couple left. And again, the party starts at 7 p.m. It's in the Club Fleda. It's like 8 tram stops from here. There are some maps I've already posted near the entrance on how to get there. Free food, free drinks, and free fun for all who join the party. That's pretty much it. And again, welcome on the second day. And with that, I'm going to hand it over to Hugh, and you will introduce everything, right?
Thank you, Radek. Good morning, everybody. Everyone looks very excited to see this amazing OpenShift-on-OpenStack demo that we were going to do for you this morning. Woo-hoo! Before I get into it, I just want to put in a plug for DevConf US, which I am co-chairing. Probably I will regret that later, but I want to put in a plug for it. The call for papers opened yesterday. So if you are in Boston or you are going to be in Boston in August, please put in a talk. Even if you're not in Boston and we can get you there, please put in a talk. We're hoping that one day it will grow up and be as spectacular as the original DevConf here. So why are we doing this? We last year did a thing with Tim Burke where he got up and had folks here in Brno demo the open source stack that we ship as products in Red Hat. And we went all the way from the OS up to OpenShift, CloudForms, and middleware with stuff that eventually turned into OpenShift.io. So we decided this year we didn't want to do another installation demo because installation is kind of boring in the end. This year we're going to do something a little bit more practical and real. And we decided we would do a fairly complicated integration in which we will set up OpenShift on top of an OpenStack cluster using ManageIQ in the UI. What's interesting about this is that we're going to do one OpenShift Kubernetes pod on bare metal, and another pod on OpenStack VMs. All of it's managed by OpenStack, and the bare metal is deployed by the OpenStack Ironic project. So this is pretty exciting. We just got it working for real last week, and I just want to say, before we get into it, I apologize. It's a little bit complicated. The network topology is wild. Tony will take you through all of that and show you how he actually did it. And I'm super proud of these guys for actually pulling it together. We weren't sure it was going to happen, but it did, and it's going to be great. So without further ado, I will turn it over to Angus Thomas, who will get into in more detail what we're going to do here and take you through the presentation. Thank you very much.
All right, good morning, everybody. As you said, I'm Angus Thomas, and I would like to start off by talking a little bit about integrating projects and why we're doing what we're doing. So, I think a lot of you are aware, and Chris Wright talked yesterday morning about open source as a sort of engine of innovation, and there are a huge number of very successful open source projects, and technology has been completely transformed in recent years by a whole lot of projects. What we've been doing, and what we want to talk about today, is work to integrate multiple projects to solve real-world problems. And those kind of integrations, they bring in an extra layer of complexity, and we're going to talk about some of the technical challenges and how we solve them, and so on. But what we want to demonstrate is that when you bring projects together, you can have a powerful multiplying effect. You get projects which have a huge amount of utility in themselves. You do the hard work to integrate them, and you end up with a, something which delivers even more value to users. Next slide, please. That's quite all right. All right. So in integrating projects, one of the challenges, and this isn't going to be a talk about sort of politics and group dynamics and so on. We're going to talk about technology. But one of the challenges with integration is that people get very invested in the project that they work on, the thing that they put their time into, they get results on, and where the community in which they exist. And that passion and commitment is the engine of open source development. And everybody, I think, who's contributed understands that dynamic, and that's really what drives all the success that I talked about. But if we're not careful, and I think this is the challenge that we all face, a shared sense of identity and a shared purpose and the things that hold a community together can end up being an obstacle in some ways. So one of the things that, when you have a group of people with a shared purpose, and they're disparate, they're from different places, they're from different backgrounds, they don't know each other very well. I'll give you an example, since I'm British, of football fans. Manchester City fans, they're a disparate group, and sometimes, they can almost define themselves by not being Manchester United. And that kind of group mentality where you say, well, we're over here, we're not over there, and part of your definition is what you are not, that's exactly the kind of impediment that I'm talking about. And integration work has to push through that. So it's a challenge on all of us. It's not only about across projects. It's the same kind of thing which can put barriers in the way of developing diverse and inclusive communities within projects. The challenge on all of us is to look outward, to reach out, and fundamentally to build bridges and not walls around what we're doing. Thank you. So one other practical observation about integration is it's possible as a contributor to a project to sort of take a fairly narrow view and say, this is the camp in which I operate, this is what I do. As engineers or contributors, our users don't really have that privilege. When you are building actual useful solutions with software, you have to work with disparate hardware, with software from different vendors, from upstream projects, and you have to do the real hard work of integration. And any of you who've been systems administrators and so on will understand exactly what I mean. So part of the problem with developers taking this slightly inward-looking, narrow view is you push the work onto the users. And that's part of what we want to talk about today, doing some of the integration work to make life easier and deliver more value to users. Next slide, please. All right, enough of the philosophizing first thing in the morning. Let's get into the details. We are talking specifically about OpenShift on OpenStack. There are some really excellent presentations about OpenShift here at DevConf, which I heartily recommend that you attend. As this slide says, it's essentially a container application platform. It manages orchestration of containerized applications. It's got a whole load of automation tooling. Yeah, I'm not going to get into everything about OpenShift right now. There are better presentations than I can do. OpenStack is essentially, it's infrastructure as a service. It takes hardware and makes it into a consumable, on-demand, flexible set of resources which people can use in different ways. And the relationship is essentially what this picture represents. OpenStack is providing infrastructure in a flexible way, and OpenShift is consuming it and making it useful to developers. So, by putting these things together, as I said, the point is to come up with something where the whole is greater than the sum of the parts. So when we combine these two things, and we're about to get into the details, OpenShift is benefiting from a project called OOO, which I'll talk about a bit more, and the ability to automate the inspection and deployment of hardware, and OpenStack's ability to take a data center and bring it under centralized control, make it into a flexible resource. OpenShift is also running on bare metal, or optionally virtual machines. Now, we still have the advantages of effectively using a cloud service, quotas, metering, and on-demand provisioning of resources and all of that stuff. But we also have execution on bare metal, which has performance implications, which we can talk about a bit more. OpenStack is benefiting from getting an excellent container orchestration engine integrated into its array of services which its users can consume. And ultimately, the users are benefiting from a more flexible, manageable, capable platform. So a couple of things I want to point out just to draw attention to in case they're not obvious when we get into the details. We are talking about cloud provisioning of physical machines, as well as virtual machines here today. So when you have physical machines provisioned as a cloud service, there's a few benefits which arise. You get to run containerized applications directly on the real hardware rather than on a hypervisor, which means that you get more computer capacity out of your hardware. There's other advantages, like if say you're doing a whole load of calculations on graphics cards without a hypervisor layer, you don't have issues with pass-through. There's a whole bunch of complexity that's taken out of the picture by just being given bare metal. But you still get machines on demand. You can still do dynamic scaling and all of the things you'd expect from a cloud service. Excuse me. All right, so as I think Hugh mentioned at the beginning, we're going to see provisioning of an application on both virtual machines and bare metal, just to make entirely clear what the subtleties of what's coming up are. Next slide, please. Couple of things to point out in the context of the whole thing we're going to build. ManageIQ. ManageIQ, some of you will be aware of it, I suspect some of you contribute to it, is a sort of a management platform that can go across multiple different underlying platforms, can give you, and providers rather, give you a single pane of glass and a single view of your infrastructure and your workloads, and you'll see ManageIQ up on the screen sort of revealing what's actually happening with infrastructure. And the other part is Courier. Courier is what enables some of the networking that we'll get into. Courier basically is a project which allows multiple layers of software-defined networking, OpenStack and then OpenShift, allows them to sort of integrate and coexist, flattens the layers, and avoids performance impact from having all of this abstraction. So, all right, that's the context. Very quickly, the first thing that we have in building our our stack that we're going to talk about, is the deployment of OpenStack itself, for which we use a project called O. O is an upstream community within the OpenStack world, and what it supports, as it says on the slide, is planning deployment of OpenStack, or indeed something else, on physical infrastructure, network, topology, and all of that stuff, actual deployment, and then operational management. So O is the first thing. It takes a bunch of machines and turns it into this flexible infrastructure as a service that we're going to build everything else on. A particular shout out for Ironic. As part of O, Ironic is essentially a hypervisor for physical machines, and it supports discovering hardware, inspecting it and profiling it, managing what we call ready state, if you need to configure BIOS versions or all of that stuff, that's scoped into the Ironic project, and then provisioning and putting operating systems on it, lifecycle management for machines and so on. Dimitri Tansar is going to be talking more about Ironic this afternoon if anyone wants to hear more about that particular project. But I wanted to call it out because it is the thing that enables this physical hardware to suddenly become flexibly usable. And in the stack that we're going to get into, we actually use it twice. It's more or less the first thing we use to deploy OpenStack at the bottom layer. But then when we start serving physical machines to cloud users on demand, that's also Ironic. So it's a big enabler of what we're doing. Next slide, please. All right, so I'm going to finish with this. The sum of what I have talked about so far really gets us to this point. You're going to be sort of seeing this diagram again as we build this thing up. We have a bunch of machines. By using the O project and Ironic, deploying OpenStack, you end up with a flexible, adaptable infrastructure service, and that's what we build on, and Tomas Sedovic is going to talk about that.
Thanks, Angus. All right, so I'm going to walk you through how we install OpenShift. Can you, yeah, thank you. But before we do that, I'm going to walk you through what we're doing, what we're actually trying to achieve. So we will install OpenShift on top of OpenStack with a couple of twists. So Angus mentioned we are going to use a sort of hybrid environment where some of the OpenShift nodes are going to be running virtualized on OpenStack as is usual, but some of them are going to be bare metal nodes provided to us by Ironic. Another thing, we are going to use Courier for networking. So traditionally, if you try to install OpenShift on OpenStack without any sort of deeper integration, you would end up having two network overlays because OpenStack has an overlay to provide connectivity between virtual machines that are running on different physical nodes, different compute nodes. And then OpenShift, unaware of this, running on top of OpenStack is going to have another SDN solution, another overlay for connecting containers on different OpenShift nodes. And so Courier lets us, it's an OpenStack project that lets us connect containers directly using the Neutron layer. So we no longer have a need for the extra OpenShift SDN solution. We all manage it via Neutron. And then finally, we are going to drive the installation with ManageIQ. So rather than calling Ansible directly and going to the command line, we can order an OpenShift deployment on an OpenStack cloud with ManageIQ. Next slide, please. Yep. All right, so the process itself, we start with ManageIQ. This ManageIQ instance is configured for OpenStack, so it has the credentials. It's able to call out to the various OpenStack APIs to produce, to order any resources that we want. And it's also configured with Ansible, which is important because the sort of typical official way of installing OpenShift is via this project called OpenShift Ansible. And that's, as the name suggests, a set of Ansible playbooks and roles that install OpenShift. Now, historically, OpenShift Ansible only cared about the installation part. You had to have all your resources ready for OpenShift installation. So you had to have all your nodes ready, networked, and all the rest of it. Recently, we've added support for asking for the resources necessary from the various cloud providers. So you can now get the OpenShift Ansible repository and order, say, AWS resources and install OpenShift on top of them using OpenShift Ansible. You don't need any external tools. Similarly for Google Cloud Engine, and important for us, OpenStack as well. So the deployment itself, the deployment itself is going to be in two phases. The first one we call provisioning, where we actually gather the OpenStack resources that we need. And then the second phase is going to be installation, where we install OpenShift on top of those resources. Thank you. The provisioning phase, so we start with a playbook that talks to the various OpenStack APIs to give us the resources that we need. So in our case, that's going to be talking to Nova to give us the virtual machines that we want. It's going to be talking to Ironic to provide us with the bare metal nodes that we're going to be using as well. And then finally to Cinder and Neutron for our storage and networking needs. And then the second phase installation is relatively straightforward, at least conceptually. So we, again, run playbooks that talk to the nodes that we've created in the previous step and install OpenShift, which means download all the dependencies, configure all the services, run them, add the containers that OpenShift needs internally, and so on. And so at the end of this process, we end up with a fully functioning OpenShift cluster that's running partially on the bare metal and partially on virtual machine nodes. And that's the end of sort of my presentation of the talking part, really. Now we're going to show you a recorded demo of this. Can you play this? Now, the entire deployment process takes about 40 minutes, so we cut out the parts where nothing happens, and it's under 2.5 minutes. But you know, if you actually try this at home, it's going to take longer. So we start with OpenShift. We start with ManageIQ, and go take a look at the catalog item that we've created for installing OpenShift. And this, importantly, is running an Ansible playbook, and it has two configuration options: the number of bare metal nodes that we want and the number of virtual nodes that we're going to use. And these are application nodes, so OpenShift has sort of different kinds of nodes, but we're talking about the ones running the actual workloads. When we order the deployment, we're going to select 2 of each. So we're going to have 2 virtualized workload nodes and then 2 bare metal nodes for workload. And when we submit the order, it is going to, after a while, it's going to say that the order has started, which is now, once we refresh the page. Yep. And so now the Ansible playbooks have started running and calling out to the various OpenStack APIs to gather the resources that we need. And when we take a look at the deployment in progress, you can see the Ansible log inside ManageIQ. And so now this is the part where we skip it to when the installation finished. Imagine it's 40 minutes later. And the status is successful, so the deployment succeeded. We now have a fully functioning OpenShift cluster, and we can see all the playbooks that were run in the process and how long they took. And then finally, what we're going to do is use ManageIQ to take a look at the cloud topology that we ended up with. And so this shows all the various nodes that we've created, virtual as well as bare metal. There's also going to be one odd node that's running the actual OpenShift, the actual ManageIQ instance. We happen to run that within OpenStack as well. Doesn't have to be, but why not? And finally, we are going to take a look at a similar view of the network topology. It's a little busy. We're going to filter some of the stuff out. And it, again, shows all the nodes that we have, but also how they're networked together. So the 2 nodes up top, they're the bare metal nodes. And then the next 4 are the virtual nodes that we have. And that's it from me. Luis is going to walk you through running an app on OpenShift using CloudForms again. Thanks.
So thank you, Thomas. Now I'm once the OpenShift Ansible has been installed, what I'm going to talk about is about how to actually create a workflow, a workload from ManageIQ into this OpenShift deployment. It's going to be basically a guestbook application which has a front end and then a back end, which is a Redis master and slave. And we will decide if we want each component or not running on a virtual machine or a bare metal node. This is the first schema just to show how the environment looked like after the OpenShift Ansible execution. And what we have here at the top is that we have created a bunch of VMs and bare metal node, as Thomas just saw, and we have installed OpenShift on top of that. And that allows us to actually create some containers on top that will in turn be running on either a bare metal node or a VM node. Thank you. Now, also, Angus and Thomas mentioned a little bit about that we are avoiding the double encapsulation by using Courier. So I'm going to say a few words about how this happened. So the OpenShift Ansible actually has also installed two different containers, which is one Courier controller and then one Courier CNI per each bare metal and VM node. And those are basically communicating or being kind of the carrier between OpenShift and Neutron components. So whenever a Courier controller is watching the OpenShift API, and whenever a new service or new pod request came in, a Courier controller will be in charge of calling Neutron or load balancer to get the needed resources, like for instance, a Neutron port for the containers or a load balancer for the services. This is an example of a VM-based node where the Neutron agent and the OBS VR end was created by OOO, and then the VM and all the components inside were created by OpenShift Ansible playbook execution. And basically, when a new pod gets to be created, the OpenShift node origin create the pod, and it talk to Courier CNI to actually get the networking for that pod. And there is slightly different here. We are using a Neutron functionality called Neutron trunks. That's how this VM can have different containers inside that will be connected to the Neutron network. And Tony will give more details about that later on. But basically, in this case, for the VM-based case, the Courier CNI basically just create a VLAN device to connect the container namespace into the virtual NIC of the VM. And it will be tagged with some VLAN tag that the OBS VRInt will remove later on. For the bare metal case, we will have pretty much exactly the same, but removing the VM there, and all the components will be installed by OpenShift Ansible instead of by OOO. And the Courier CNI just need to know that instead of having to use a VLAN device, it just needs to use a BEF device to connect the container namespace to the directly to the Open Virtual Switch bridge. Next slide. So once we know a little bit about the internals, this is how we are actually going to create our workload on top of the deploy infrastructure. We are going to use ManageIQ, and we are going to use OpenShift templates. ManageIQ doesn't allow you to create those templates right away right now, but we can create it in OpenShift, and it will appear in the inventory template that ManageIQ has. And these templates, basically what they are, it's like a YAML file or JSON file that contains different objects that you can create within your OpenShift project, like containers, services, build configuration. You can also apply some labels. And the important thing is that you can actually parameterize it. So that in this case, what we are going to do is to be able to decide if this front end or this back end are going to be running on a containerized, on a VM node or in a bare metal node. And similarly, we can decide, for instance, the number of replicas that we want for the front end or the back end. So we are ready to go for the video. First of all, what we need to do is to include the OpenShift installation into ManageIQ. And has it started already? Yeah, you need to click play. And to do that, we need to, well, we first check that there is no installation, no provider for OpenShift yet here. So we are going to go and check in OpenStack, which is the VM that has the master role for the OpenShift deployment. And we will log into it and check what application nodes are register in OpenShift, which has 4 of them. 2 of them are the bare metal ones that we requested, and 2 of them the virtual ones. And we will see the difference between them. If we try to get information about one of the VM ones, which are the .13 or .5, we will see that it has a type attack that says that it's of type bare metal, and it has nested VLAN as a pod beef. That is what CuriousCNI used to actually know that it needs to use a VLAN device to connect the pod to the neutron networks. And for the bare metal case, we have the same, but type is bare metal, and pod beef is neutron beef, meaning that you need to use a BEF device instead of a VLAN device. Now we are going to import it into OpenShift and into ManageIQ, sorry, and we just need to give the floating IP of the OpenStack VM that has the master node, check their credentials that they are correct, and then just add it. This will automatically, in ManageIQ, load information about this OpenShift deployment, where we see that it has, for instance, 6 nodes, the 4 that we have seen, 2 VM ones and 2 bare metal ones, plus the master and the infra node that OpenShift usually deploys. We can see this a little bit better on the topology, where we can actually differentiate between the bare metal and the VM node. If you see there at the top, there is a node which has like a gray box attached to it. That means that it's running on a VM in OpenStack, and it has a Courier container running with that configuration. And then there are other nodes that doesn't have this VM attached, meaning that those are the bare metal nodes, which also has a Courier CNI running with a different configuration. So now it's time to actually create the workload, the guestbook application. So first we go and see the container templates that there are available. There are some examples, and we are going to create the guestbook application. So we just quickly go to OpenShift and create one example, and it will appear here, and we will check what parameterizable option it has, like if we want to run the Redis master or slave in a VM or a bare metal, same for front end, the number of replicas, as well as the objects that this template has, deployment and service, one for each kind of component. Now we just create a dialog so that it will ask us about this information when creating this workload. We just give it a name. And then in order to consume this service, to be able to actually create this template from ManageIQ, we need to create a catalog item where we actually are going to consume later on. So first, just click on catalog item. We need to tell it that this is an OpenShift template. Just give it a name. We will associate it to the catalog that we already have for the OpenShift, but we can associate it to any other. We will tell that we need to use the dialog that we just created so that it asks for these parameterizable options, the provider that we created, and the guestbook application or template that we have. And once it's added, we can actually start consuming it. So we go to the service catalog, OpenShift, and then we can just trigger or order this service, and it will ask about these parameterizable options that we have. So first, we are going to create an OpenShift project called devcom for this demo, and then we will decide that the Redis both master and slave will run on bare metal for performance issues, and then the front end we'll leave it on the VM, but we will decide that the number of replicas is going to be 3. Just add it, and this will go from pending to active and to finish, and we actually can check in the OpenShift command line that this project got created to devconf, and if we log into it, we will see that there is 5 containers, 3 of them for the front end as we requested, running on the bare metal, on the VM node, sorry, and the master and slave running on the bare metal node. We can see kind of the same in the UI, that this devcom has been created and has the 5 containers that we just saw and 3 services. And we can actually also check that, for instance, the master that we requested to be on a bare metal is actually on a bare metal node. We can, if we already know the IP, we can just click there and check that is in the node .4 that was actually a bare metal node, or even go to the topology and check again if it has this VM attached or not. Here we see on the left part 2 nodes that doesn't have any VM attached, so those 2 are the bare metal ones, and we see that they are running, this one is actually running the slave, and the one on the top will be running the master container. And then there is a couple of them in the bottom part, which has a VM attached, this one, and those are the ones that are running the front end. We have 3 replicas, so they are all joined together by a service, which actually is of load balancer type, which means that it needs to have an external reachable IP. So what Courier does is asking neutral load balancer for a load balancer to it, and it will attach a floating IP to the load balancer IP so that it's externally reachable. And we can also check this from ManageIQ by going to the floating IPs and see the relation between the last column, the last row, where we see the service 1.72.30.10.8 is the service IP, and then the other one is the floating IP that we can reach from our browser. We expose the port 8080, so we see that we are able to reach the load balancer, and in turn that will redirect us to one of the front-end containers. And then when clicking submit, we will see that these front-end containers can actually reach one of the bare metal Redis master of slaves. And now Tony will give more details about the network internals that make all this work.
Thanks, Luis.
Thank you.
Thank you. All right, so now we're going to see how the network plumbing looks like. So can I have a show of hands how many of you have used OpenStack? Wow, that's better than expected. And OpenShift? And how many of you have had to go and look at the networking details for some of them? That's good and bad, I suppose. Anyway, all right, so the first slide that we have here, since this is the most special thing about this presentation, which is that we have both bare metal and VMs, is let's start with the bare metal and let's see how we do that. So the bare metal nodes are booted on the provisioning network, and that provisioning network has no access to the VM network, which is used for OpenShift to host its master and to have the OpenShift API there. So we needed some way to be able to bridge that gap. And the way we did that is thanks to this Cubelet device. And so this Cubelet device is actually on the VM network. And then the master and the slave, when they run on the bare metal node, these are the Redis pods that we saw created before. They will also get networked on the integration bridge. This is the same integration bridge without any difference that you always see on your compute nodes. So you'll see here the tab device, and then what would be the VM, in this case the pods, they get their L0 and everything works. The difference is you don't see here any metadata or any DHCP. But let's get into a video to show a bit more about how it looks once you're inside of the node and digging in. So the first thing that we'll look at is those two bare metal nodes that were created. If I remember correctly, it was the .4 and the .8. We're going to focus more on the .8 today. And if we look at what Nova knows about those machines, we'll see that it only knows about the provisioning network. That's what they were booted on, and that's all the networking Nova thinks it has. So let's look at the Cubelet ports. Those Cubelet ports have nothing special, nothing whatsoever. They're just normal ports that are used for this Cubelet device. So in order to wire the Cubelet device, what we do is we have the Neutron agent running on this machine, and through the provisioning network, it can reach Neutron. So if we ask OpenShift about the pods with this plugin that we see that the pods have these devices. Then we see that they are 2 on the 8, 1 on the 4, and that there is these tab devices associated with it, and that they all use OBS for plugging in. So this is ML2 OBS. All right, so nothing special, just instead of VMs, we're using pods. So now what we're going to do is to go inside the bare metal node and look at how the integration bridges these things. And what we see is that in this case, the deployment for Cubelet put the external IDs that are expected by the Neutron agent, and Courier, every time it sees the creation, the CNI attaches those external IDs for the Neutron agent to pick them up and to wire those devices. And if we look at the tags that are seen by it, we see that there is effectively a different subnet. There is the VM subnet that has the tag 1 and the one for the pods that is tag 3. So in our deployments, we do not have a subnet per each node, but we share the same. Here you can see that even though they are called tab devices, actually they are VF devices, so it's a pair. and the other one is a normal internal port of OBS. So now let's move on into the VM side. How many of you have used the trunk port functionality? Show of hands. One person. All right, two people maybe. Okay, so this is a not very well-known functionality which allows you to take any OpenStack Neutron port and say, okay, I'm going to create more ports, and they are normal ports as well, but I'm going to put them sub-ports of that other port, so that they are expected to somehow flow through that parent port, as it is called. So in this case, you can see here, this is the front-end pods that we run, so we focused on a single virtual machine for this diagram. And you can see that there is a tap device for the VM, as usual, nothing changed. But apart from the integration bridge, we have a trunk bridge. This is SDN implementation dependent, so if you use OVN, you're not going to have this, but it's going to have some wiring instead. But in the ML2 OBS case that we use here, we see that this is the parent. You see PT is parent. And this is the one that will carry the normal communication of the VM. So in this case, what the Cubelet, what OpenShift node will be using to talk to the OpenShift master. And then we have that when pods are created, they get assigned a VLAN ID. This is the segmentation ID. So all the traffic from front-end A to front-end B, if there was a need for such communication, since it is tagged, it would not be able to just flow inside the VM. It would have to go here, be untagged, get to the integration bridge, and then, until here, that they're on the same subnet, they will not be able to flow back up. And what we get by doing this is that we ensure that all your security group policies between pod traffic still get applied. So let's go and look at the demo about how this looks like once you go into both the VM and the bare metal compute node. So let's just start by looking at those pods that are running the front end. So we select for tier front end, and we see that there's these two pods, and the information about them, the matching F1 and F4 that we saw in the diagram. And now let's look for the machine where they're running, which is the 13. And this we do to be able to find the port UUID and to ask Neutron about the trunk details about one of the subports. So here we select the UUID, and we see that it actually matches. So it's this front-end B that has the tag 1, and that gets untagged here to be sent to the VRINT. So now what we're going to do is to ask OpenShift what is the container ID for Docker. So this is a bit container runtime specific, which is this one. And thanks to this, we'll be able to run a command inside the Docker network namespace. And we will ask about what configuration the Docker container sees. And the only configuration it sees is that it uses a normal VLAN device, as Luis said before, and that it's the tag 1. So it matches, and the communication will be tagged from its perspective. So which bridges we have? We have, in this compute node, the integration bridge and 2 trunk bridges. So this means that in this compute node, there is another OpenShift worker node. And now what we're going to see is which is the one that is actually being used by the pod that we're looking at all the time. And we see that it is this 7 here, 7B. And the communication between different nodes would also go to BRINT. So that is an important detail in terms of security. And we see that the SPT on the trunk port has as a pair the SPI. So it's patched in this way. And finally, like, you see the whole flow. So now that we saw how everything is networked in terms of connectivity and IP networking, let's look at how the services work. So in this presentation, when Luis went and used the website, he used a load balancer service type. So a floating IP would get assigned. So that gets translated by the router. And if you used OpenShift, probably you had the services implemented by kube proxy, which is not what we use when Courier is involved. We implement the services by putting a load balancer, as you can see. And this is a normal LBAS v2 load balancer. So if you use a network implementation that uses that, it's just going to work. It's just going to get translated. So you get for each service, you get a load balancer, and then depending on how many ports that service exposes, you're going to get more listeners and pools. And finally, all the pods that implement that service are going to be members of that pool. So when you talk to a service, you're going to get whichever of the pods that are running inside or that are backing that service. And with that, you now are able to debug all the network issues that you get with this integration, so you don't need to email me. And I'll pass it back to Angus to wrap things up.
Thank you, John.
All right, thank you. So, having got into the details and shown you some of the complexities of the problems that the engineering team was solving, yeah, to sum it all up, integrations of this, like this are hard, but the benefits are huge. When you look at the combined stack that we just walked through with OpenShift on OpenStack, Courier is the enabling network tier in the middle, you end up with a stack that has some pretty compelling capabilities. It's got the ability to discover and inspect physical hardware, managing hardware state, automating OS deployment and application provisioning, bringing a whole data center under managed control. It can provision infrastructure on demand to users, including provisioning bare metal to users on demand. It can do quotering and billing and enable all of that stuff. When users are finished with their bare metal machines, they can just hit delete and walk away, and the infrastructure magically takes care of managing all that stuff in the background. And then it's got the ability to do orchestration of containers with all the rich automation capabilities that come with OpenShift. You can arrange that across virtual and bare metal machines with integrated networking. And, excuse me, the sum is that the utility that people get is greatly enhanced, and what you have is much better than any one individual component in isolation. All right, now, thank you all very much. I think we have a couple of minutes for questions if people would like to ask questions, and the guys can come back up and answer some very technical questions if there are some.
I know everybody got all that on the course.
Oh, there was. All right. I'm sorry.
I heard it. I'll repeat the question. Yeah. All right. So the question was about details on the floating IP and the load balancer VIP. So the way this is done is you configure Courier, telling it which is your public network, and then the difference between a load balancer service and a normal cluster IP service, cluster IP are not reachable from outside. So we just take the service that we created, the load balancer, with its VIP, which sits on the service network, which is it's the same network that you tell OpenShift that all your service IPs are going to be in. So that's the VIP. And we just take a floating IP and assign it to the VIP of the load balancer. Yes, for the floating IP to load balancer service, it's definitely nothing on the router level. That's why I had the router on the slide. I just didn't explain this properly. Sorry. You're welcome. There was a question about around there. Yes. All right.
Okay, so I think the question, if I can paraphrase it, was about the complexity of on-premise software and Okay. Well, it's a challenge. I mean, you know, your feedback is valuable to us. Clearly, there's better that we can do in terms of communicating how to use products. Partly, it is just extremely complex stuff. You know, I mean, as we just saw with the courier networking, you can only sort of simplify by, at some level, eliminating details which are important to at least some of your audience. So it's a continuing struggle, honestly, to convey very complex information in a consumable form. That's actually not really my area of expertise, as you may have begun to judge from listening to me. But we work on it. We have people who are, you know, that's their entire job. We're investing in trying to do it better. But it's hard because, to some extent, the problems are irreducibly complex. Okay, I shall let Tony take this particular question.
So the question was about Istio and Courier, and the answer is that right now we're working on, we're exploring that, like how the service mesh will work with Courier. It's not something that it's not the first priority right now because we are working on making this ready as a product and reliability in the way that you saw it now. But just after that, obviously, Istio is the big thing that we're exploring in terms of forwards compatibility together with multiple interface per pod, which is something that people are wondering a lot about. And for example, Samsung is contributing SRIOB support and so on. So there's a few things that we're looking for the next release, and Istio is one of them.
All right, I think we're out of time. Thank you all for coming. I want to also give special thanks to all the lovely graphics in the video, the stuff that actually made sense. That was done by